the recording. Okay. Good evening, everyone. Today we are going to do our Chapter 5 selections and conditionals. And we have touched some parts of this in Chapter 4. So it's supposed to be an easy chapters for this week. First, we will review something like for the printf. Printf is a little bit similar to the print line, right? Sometimes when I was coding, I will change the SOUT, which stands for the system.out.println, print line, instead of printf. But sometimes I use printf because when I want to format the output, I will use that. For this function, it can place the number of decimals that will be shown when printed to the console. Like it use a percentage symbol with some other numbers or keywords to be the placeholder, and then it will be replaced by the following variables when this line was executed. For example, in the first line, the SOUT out printf %.5.2f. And after that, it is a variable or constant. We say that is a decimal point number. And when we executing this line, the %5.2f will be replaced by the 5.12345 when this line is executing. And the same thing is happened with the second line and the fourth line. So in this case, the number 5.12345 and 6.23456 will keep only 2 digits as the format. As the printf, it puts a .2f there. That means only return the 2 digits after the whole number. The second thing we are going to review is the scanner. We use the scanner a lot of times, right? Like when we want to input something from the console, and we request the user to input something as a certain kind of values, and then we assign that values to a certain kind of variable. So we use the scanner. We say it is a built-in classes. And we never mentioned a lot for that because it's a little bit out of the scope of the beginning and the junior Java class. But here we will introduce something more. Like for the scanner, there are some more methods to use. For example, we use the next parenthesis. Usually we use the next dot, right, and next int or next double. That means that means the program is going to read the certain kind of data types or variable types we are going to read. If we are not using the next integer or next double, that means it only reads a token. Any token is fine. And there is another thing that is the next line for this method. That means we can input a whole line in the console, and the next line method can read a line of text. So for the if statement, there are some motivations, like we are going to figure out whether it is rains today or not, and if we are wearing red, or whether your eyes are blues or brown, or whether if you rode your bike to school or take the bus. So that means those conditions will allow you to make decisions using your programs. In this example, that is if a certain kind of conditions is placed between the parentheses, right? And after the if condition, there is a statement that is matching to the condition. And we talk something about the Boolean expressions. So here we are going to talking about the Boolean types and operators first. Often in the program, you need to compare two values, such as whether I is greater than J or something else, or like today is Sunday, whether it is true or false. And Java provides 6 comparison operators. Also, it is known as rational operators that can be used to compare two values. And the result of the comparison is a Boolean value. A Boolean value means that it can only have two potential candidate output. The first is true, the other is false. So here, a Boolean type B, right, is equal to 1 bigger 2. That means you have to make the comparison if 1 is bigger 2. In this case, since 1 greater than 2 is false, so that means B is false. And here is the overall 6 rational operators. Less than or equal to, greater than or equal to, and the two equal symbols, we say that is the true equal to. So let's recall, what about the only one equal symbol there? We say if there is only one equal symbol, that means we are going to assign a value to a variable, right? Like we say, we declare an integer, we declare a variable that is I, and we assign the number 10 to the I. So the whole code would read as follows, like int I equal 10. That means we assign the value 10 to the variable I. We bind them together. That is not real equal. However, the double equal symbol, like listed in the 5th line, it is true equal. That means, for example, here the radius is 5, right? If the radius is equal to 0, since radius is 5, 5 is not equal to 0. So the result here is false. And the 6th line is not equal to. And this is one-way if statements workflow. If the Boolean expression, and then go to the statement. In this example, in the example listed on the right-hand side, right? If the radius is over 0, we go down, which means it is true. So in the downside, we calculate the area, which is calculated as radius multiplied by radius multiplied by pi, and then we output the areas of the circle. However, if the radius is equal to the radius greater or equal to 0 is false. That means the radius is smaller than 0. So the program will route across the calculation for areas and go directly to the end of the program. That is the one-way if statement. And here is a note that in the left side, it is a wrong way to write our Boolean expressions, as we have to using a parenthesis to wrap the Boolean expressions within it. And in the right-hand side, this is the correct format to write the if statement. And also, in the second line, if your if statement only contains one line of code that is matching to your Boolean expression, in this case, that means if I is greater than 0, there is only one line of your program the program need to execute. That is, output the I is positive, right? So in this case, you do not need to write the curly brackets. However, if you are going to do something else, like you are doing the self increment to the I, and or maybe you are doing something else, you have to using the curly brackets to wrap all the things inside of the curly brackets to make it formed as a code block. And here is the two-way if statement. That means the Boolean expressions only contains two results. One is true, the other one is false, right? If it is true, the program goes through the left branch. Otherwise, it goes through the right-hand side branch. And this is the example. Also, it is looks similar to the one-way if else statement, right? And of course, there are multiple alternative if statements. We have done it in our labs, right? We are mapping the score to the letter grade. We are when we are doing that, we're using the multiple alternative if statement. Like if something in the left side, it is a nested if else statement, because when we are doing the else branch, in the else branch, we contain another if else. And in the right hand side, in the block indicated by B, it is more formatted. It is a truly multiple alternative if statement, because each time you can only select one branch. Like for example, given a specific score, you can only select one of the fifths, 1, 2, 3, 4, fifth, 6. You can only select it from the 6 candidate paths. However, in the left-hand side, each time you should make your decision in between two different decisions, but they are equivalent. And we would suggest that when we are coding and we are doing some programs, it's better for us to using the right-hand side way, because it is more visual friendly. And here is the visualization for the nested if else statement, which is mapping to the A block. So this is mapping to the A block. Okay, and then this is a trace if else statement. So suppose the score is 60, and in the first branch, the condition, we say the Boolean expression score greater or equal to 90, this condition is false. So we move to the second Boolean expression, which is comparing with 80.0. And however, this is still false. So we move to the next Boolean expression, and then we find that, oh, this condition is true. So in this case, we output the grade 70 as C. And after that, we exit the if statement. However, we should note that to force the else clause to match the first if clause, you must add a pair of braces. That means I would suggest that you, every time when you are writing your code, no matter whether there is one line of your statement or multiple line of your statement of code, every time you use the braces to avoid or we say to prevent the mistakes there. And for example, here, like it used a semicolon in the first line, which is after the Boolean expression, while before the left curly braces, right? This is wrong because when we are using the semicolon, that means this line of code is going to execute and terminate. And when we are writing the if-else clause, and we should making the else always match the most recent if clause in the same block. If you are going to take in the Python course, well, the indent is pretty important because in the Python code, we don't use the curly braces. Rather, we use the indent to stands for different code blocks. But in Java, it's fine. Although it is fine, but it's better to correct the indentations when the if-else statement, they don't match together. And this is some tips for you to write your codes. Like in the left-hand side, we say in the A block, if number mode 2 is equivalent to the number 0, and we set the even is true, else we set even is false. And we can simplify it into the B block that we declare a variable named even. And we assign the number mode 2 equal to 0. We assign this result to the variable even. So here you have to, okay, let me get a pen. You have to distinguish here. It is only one single equivalent symbol, right? Here it is double. So this goes first. After that, this value, this result will assign it to the variable even. I cannot. Okay, actually, okay, I think I should remove this. Let me remove it. And for this line here, they are all also equivalent. In the first hand side, we use a if statement, right? If even is equal to true. However, for such a thing, we can place the even there. Why? Well, I would say that is because I think it's better to type there. I cannot. It is because, okay, let me get okay, text box here. It is such a thing, like if we are declaring a Boolean value, right? We say that is a flag. Usually, if the flag is equal to 0, that mapping to the things is flag is false. Otherwise, flag is true. That means no matter flag is equal to 1, 2, 3, or 100, as long as it is not 0, we can take it as true. That is the thing. So that's why we can use the even rather than even, which is equivalent to true as the Boolean expression. And here is a certain kind of problem that which is pretty similar to our lab problems. Here it is say that the U.S. federal personnel income tax is calculated based on the filing status and taxable income. There are four filing status: single filers, married one, or the married one was divided into two different categories. The first is the married filing jointly. That means the wife and the husband, they file their tax together. The second one is the husband and the wife, they file their tax separately. And the fourth one is the head of the household. That means you have a big family and the head of the household file the tax for the whole family. And there is the related rates are shown below. And we can say that here, for the status, we assign the four different kind of categories using the number 0, 1, 2, 3, 4, which is mapping to the like single here. The first one is computing for the single filer. The second one is for the married file jointly or qualifying widow. And the status, which is equivalent to 2, stands for the married file separately. And the status 3 means that we should compute the tax for the head of the household. And there is an else pathway at the end, which means we should display the wrong status input. And then we're going to introduce some logical operators. The first one, okay, let me check what is the name of this symbol. Oh, that is exclamation, which means not. And the double N, which is means the end, means the logical conjunction. And the two vertical bar means or, that is logical disjunction. And upper dictate, which means the exclusive or, means that is logic exclusion. So here, this is the truth table for the operator not. For example, here, if the P is true, so the not P means false. An example is that assume the age is 24 and the weight is 140 pounds, right? So age over 18, it is true, right? If we put the not in front of this expression, so the not age over 18 will turn to be false. And in the second example, that if P is false, not P means true. For example, the weight, we suppose it to be the 140, right? Here it is making equivalent comparison with the 150. Of course, they are not equivalent. So inside the parentheses, it is false. However, if we put the not symbol in front of this, before this Boolean expression comparison, that makes the whole expression to be true. And for the operator and, we say, for example, if P1 is false, P2 is false. So since two thing is false, right? So P1 and P2 means they are all false. We are using the same example, like if H is smaller or equal to 18, and weight is smaller than 14, which is false. Because each individual of the comparison, that is the age, we say it is 24, right? It is not smaller or equal to 18. It should be greater. And the weight is not smaller than 140. It's supposed to be bigger or equal, right? So the two individual comparison is false, making the whole expression is false. And we say that when we are using the operator and, if one operand is false, the whole expression is false. That means if P1 is false and P2 is true. So a false and true is equivalent to false. Like if the age is smaller than 80 and weight is equivalent to 140, that means the first expression, age comparison, is false, right? And we use an and to concatenate it with the second expression, which makes the comparison with the weight, which is true. However, since the first expression is false and the second expression is true, so in this case, that means the whole expression is false. And that is the same thing when the true and the false, they exchange to the different operators. Like this time the P1 is true and the P2 is false, according to the third line here, right? Suppose this time the age is over 18 is true, while the weight over 140, this is false. So that makes the whole expression is false. And the only scenario when P1 and P2 is true only happens when P1 is true and P2 is true. That means you have to meet the two criteria at the same time. Like the first one is the age is over 18, and the second one is the weight is over or equal, since there is an equal, right? The weight can be equal to 140. So the two expression is true, makes the whole expression as true. And the truth table for the operator or is totally different. For the operator or, as long as one of the P1 and P2 is true, the whole or expression can be true. As we can see from this table, there are three true, right? And only one false. And the only one false only happens when P1 is false and P2 is false. That means you have two criteria. As long as you meet one of it or two of it, and then you pass. Otherwise, you fail. So the first case, P1 is false, P2 is false. That means you didn't meet any one of the criteria. So that makes you false. However, the second, the third, and the fourth scenarios, you meet at least one of the criteria. So in this case, you passed this expression. So that's why the P1 or P2 is true here. And for the operator, we say it stands for, let me see, what is the English name? Exclusive or. Exclusive or is a little bit it is a little bit quite different. So I should give me some time to take out my pen and drawing table. Okay, okay, it's fine. So here, the exclusive or means that, where is my pen? Okay, I find it. Oh, why I cannot using? Okay, I can use it now. For the exclusive or, that means I did something wrong with my. That is means that when, oh, I use a wrong pen. Okay, sorry for that. Now it's fine now. So exclusive or, that means I give you a P, right? I give you a P, I give you P1 and P2. As long as they are different, that means if the P1 is 0, P2 is 0, so P1 and P2 is 0. However, as long as they are different, that means P1 is 0, P2 is 1 here, right? Or we exchange the value, the P1 is 1 and P2 is 0, right? They are different because P1 and P2 is different. That means they are different. So when we are using the exclusive or, we can get the result as 1. That is true, right? However, if they are both same 1, then P1 exclusive or with P2 is 0. And when we are writing our code, it can be written in such a way, like suppose Boolean, right? We declare a Boolean variable P1 that is true. And then we declare a Boolean expression P2 that is true, right? And then we declare a Boolean variable that is, we say flag, right? Which is equal to P1 dot P2, right? So here, what is the value for the flag? So according of the truth table, P1 is true. That means P1 is 1. P2 is true. That means P2 is true right here. So the flag is supposed to be 0. But what if in another case, like if P1 is false, right? And the P2 is true. So what is the value for the flag? So we can check the truth table. P1 is false. That is this one, right? P1 is false, is 0. And P2 is true. That means P2 is 1 here, right? And the Boolean flag, which is P1 exclusive OR with P2. So we got this one. And then in this case, the flag is true. In this case, and that is the exclusive OR. And there are some examples that can be used in our codes. So let's see. Suppose the number is from the user input. Let's see. For example, if the number we assign it 2. We assign it 2. Okay, no problem. Or no, we can better bigger than the 3. So we assign it 4. So for mode 2 is 0. Okay, this is true, right? And the second expression here, for mode 3 is 1, right? Actually, it's 1. So this is false. In this case, the true and false will make the expression false, right? So the same thing for this one. And the first expression is true, and the second one is false. However, for the OR expression, as long as one of the criteria is met, it is true. And for the not, for the exclusive OR expression here, we say the first one is true, right? And the second one is false, right? So since they are different, this is 1 and 0. So we say this is true. So supplement to they are also, we can using the single X and the single OR, I mean the single vertical bar operations there. Let's see. If X is 1, what is X after this expression? We say if X is bigger than 1 and there is only one n. X plus plus is smaller than 10. So here we say this expression is those are bitewise operators. We say, let me give a more accurate example here. How can I demonstrate it? So since X is 1 equal to 1, right? And X plus plus, that is 1 plus plus, smaller than 10. So this makes the false, right? And the 2, this is 2, smaller than 10, false. So this is a bitewise AND. That means 0 and 0. We're using an operator to compare them. So in this case, it's supposed to be 0. Or we say it's or we say it's false. I don't think it's false. I think it's supposed to be a number, so we can write a program to verify it. So let me create using my IntelliJ to verify it. My IntelliJ gets stuck. So here, let me try. Okay, let me new a module. Create. So our question is int x is 1, right? We are going to compare flag, that is x smaller than 1, and x plus bigger, okay, smaller than 10. So solved. Sorry. Okay, we should put it into the main method. And so we can use the sort, and we output flag is %d flag. Okay, let's run to see the output. Okay, it throws that means they are not equal. Sorry, I should do the conversion, type conversion. Okay, I think currently it's fine now. It is still not correct. Let me see. Okay, I should ask ChatGPT to help with me. Oh, I see. It's not here. Oh, it's fine with that. They're supposed to be percentage p, which stands for the Boolean expression. So let's see. Okay, flag is false, which is the same thing as I wrote in the slides, but let me debug it. Try. Oh, sorry. I think I should make a breakpoint here. Okay, then I go to the debug. Here, x is 1. And then I go to the next line, step into. So here, x is 2 because it goes self-incremented here, right? As you can see, I think I should make the okay, this is much comfortable. Now here, the debugger indicates flag is false and x is 2 here. So let's see how the flag is compared. And what if I using the or? Oh, sorry. I using one vertical bar. That means the bitewise or. Okay, let's run it again. So it is true. That means the 1 here is false and here is true, makes it true. Okay, that is for this program. And then let's get back to the slides. Okay, that means I'm a little bit, I wrote something wrong here. For the individual, here, this place, okay, do I have the, okay, I don't have it. Let me delete it. Where is the delete? Okay, let's redo it. So here for x is equal to 1. Actually, I just make it wrong here. They're supposed to be true, right? Here is false. And what is x after this expression? After this expression, x increments, so x is 2 here. And the whole expression is supposed to be, which is equivalent to false and true here. Since this is bitwise false and true, and since there is a false in the side, in the left side, so it is supposed to be false. Usually we say it's a bitwise comparison because for the individual x and the or here, we only compare one bits by bits. For example, suppose we have a binary representation A, right? Here is, we say 1, 0, 1, 0, 1. And we have another Boolean expression that is 0, 1, 1, 0, 0, right? If we are doing with AND, so we compare them bit by bit. That is 1 and 0. That is supposed to be 0 because we are using the AND. As long as one side is false, the output should be false, right? So here is false, and there is true, because the two side is both true. And here is supposed to be false because one side is false. Here it is also false because the B side is 0 here. However, in the other case, if we are doing the OR operation, so as long as one side of the operand is true, the output should be true. So we compare them by bit. So in this bit, this is true because here there is 1 true in the A side, right? And this one is false because no operand is true. Here is true because two operands are both true. This one is true because in the B side, the B operand is true. Here is the same thing. A operand is true. So the output is true. And for the, actually, there are also bitwise exclusive OR operations. So I will complete all the examples. Suppose the same case, 1 0 1 0 1 0 1 1 0 0, and we're using the exclusive OR. So we compare them bit by bit. For the 1 and the 0, since they are different, we're using 0. For the 0 and 0, since they are the same, right? They are supposed to be 1. This is 1 because the two operand, they are 1. And for this one, 0 and exclusive OR with 1, since the two operands, they are different, so there should be 0. And this is the same thing, 0. And that is the A and B. This is the A or B. This is the A exclusive B. And that's what. That is the 3 cases. And here, let's see the second one. If x is 1, and what is x after this expression? So here, the x becomes 2, the same thing. However, how about the 2 expression? Since 1 over x, this is false, right? And 1 over x plus plus, okay, this is also false. So false, they are comparing the 2 expressions, false. That is false. And how about 1 equal to x or 10 over this one? So here, this one is true because x is 1, right? And x is over 10 is over this one, right? This is true. So that means true makes them to be true. And this is the same thing. Even though they are using the double vertical bar, here is also true. I don't think this is a good example because it only have 1 digits. And let's suppose we can change it. We can modify it. So, for example, can I change my, okay. Let me use the eraser to remove the original writing. And we will change the examples for the x. Suppose here, if x is 1, 1, we are not using 1 here. We are using 1, 1, which is the binary. Okay? It is 1, 1. What is x after this expression? Here, binary 1, 1, right? It is equivalent to decimal 3, right? Because 1 is 1, 2 is 1, 0, right? 3 is 1, 1. So that means x 3 currently is 3 over 1 is true. And x plus plus now becomes 4 and smaller than 10. Okay, that is true. So after this expression, x is equal to 4, right? Becomes 4. However, here it is comparing the bitewise and so in this case, we are comparing the x over 1. That is, we say it's true, right? Since this is true and this is true, so 1 and 1 becomes 1. So for this expression, it is becoming 1. And for this one here, using the double n, here is true, right? Oh no, here is false. Because x is 3 now. And 1 over this one. Okay, here it is also false. Now this expression will become false. But here we do not write 0. No, because here it is a Boolean. It is Boolean expression. And here it is bitwise representation. So we're using 1. That's the difference. Okay, I will use red hat. This is bitwise, so we use 1. This is a Boolean comparison, so we're using false. And importantly, we do not write 0 here. Although 0 can represent false. And that is for this line of these slides of the lecture. Okay, for the switch statement, we didn't mention about it in the previous week, but it is the same thing, not very difficult because we using the status as the Boolean expression. We say the condition, right? And we go to the case 1, case 0, case 1, case 2, case 3. Those are different branches. It looks similar to the if-else statement. So this is the overall workflow. So this is the starting point, and then we compare the status. If the status is 0, status is 1, status is 2, etc. And the switch expression must yield a value of char, byte, short, or int type, and must always be enclosed in the parentheses. Like if the value for the switch expression going to be value 1, and then it will continue with the statement 1 with a break. If the switch expression is to be the value 2, it will go to the statement 2, etc. And the keyword break is optional, but it should be used at the end of each case in order to terminate the remainder of the switch statement. If the break statement is not present, the next case statement will be executed. That means, for example, when I get the result of this expression and it is equal to here, so I will continue to do here. If I don't have break here, if I don't have break here, right? So it will go through the statement 1 and then continue statement 2. If we don't have break until we go through each iteration. So it's better to trace a program here. Like suppose the day is 2 for today, right? So it will go to this statement. So it matched the case 2 and falls through the case 3 because we don't have the break, right? And falls through the case 4 and then falls through the case 5. And then we encounter break, and when we stop the switch, exit statement. So for the condition expressions, we can, using the question mark and the column symbol, as we mentioned in last week, right? If something is true, and then we do the first expressions before the column. Otherwise, we do the second expression. They are equivalent. And this is the conditional operator. If state for the if statement. And here, I should mention, okay, here, they are equivalent. So here is the system output. The number is even, right? The number is odd. So here, we write everything in one line of code. Here, we make our decision. If the decision is true, and then we output the number is even. This is the whole expression 1. Otherwise, we will output expression 2. So they are the same thing, right? This match to this one, and expression 2 match to this one. So it makes the if-else statement into one line of code. And here is the operator precedence. That means something should operate before the other thing. Here, if that means when we are meeting an expression and it has the parentheses, and we should always calculate the things in the parentheses first. And if we meet the self-increment and self-decrement, we should calculate it first before the plus and minus or unary or the plus variables and the minus variables, that is the in front rather than the after front. That is, you can have a look over it and you will have a sense of it when we are doing our lab for next week. So the operator precedence and associativities means that the expression in the parentheses is evaluated first, and the parentheses can be nested, in which case the expression in the inner parentheses is executed first. When evaluating an expression without parentheses, The operator are applied according to the parenthesis rule and the associativity rule. And this is the rule for them. I know it's a little bit a lot, but if you are coding more, you will be getting more familiar with it. If the operators with the same precedence are next to each other, their associativity determines the order of evaluation, and all binary operators except assignment operators are left associative. Usually they are left associative, but some of them are right. And what is the operator associativity? That is, when two operators with the same precedence are evaluated, the associativity of the operators determines the order of the evaluation, and all binary operators except assignment operators are left associative. That means here, we calculate A minus B first, and then we use the result to plus C, and we do everything from the left to the right. That is the left associated. And that is also can be right in such a way using parentheses. But assignment operators are right associative. That means you are assigning a value from the right-hand side to the left-hand side. That means in this case, as we can see, we first assign 5 to C here, right? And after here, we have C is 5. And then we do this such a thing. B plus and equal to 5. That means B is becoming B plus 5, right? And after that, we assign this value. Suppose. Okay, we do not need to suppose. And after that, we assign B to A. That is from the left-hand side to right-hand side. Right-hand side to left-hand side. That is the right associativity. Examples here. So applying the operator precedence and associativity rules for the expression 3 plus 4 multiplied by 4 over 5 multiplied by 4 plus 3 in the parentheses minus 1. So it's evaluated as the following order. First, we should calculate everything in the parentheses. As we can see here, parentheses is always the first, right? So here we take the inside parentheses first. We calculate it and get the result of it to 7. And after that, we calculate the multiplication from left to the right-hand side. So here we have, let me change the color. We have 4 multiplied by 4 here, right? And we got 16 here. After that, we calculate the second multiplication, which is here, and then we got 35 here. And once we have such an expression here, we do everything from the left-hand side to the right-hand side. Since plus and minus, they have higher, okay, we're using a plus, a higher precedence than the symbol bigger, as we can see from here. So the plus and the minus here, right? It is listed. Even the binary one, they are listed before these relational operators, right? So we should apply the addition and minus first. So in this case, we calculate these two things first. And here it will result 19 here, and here it will result 34 here. After that, we make the rational operator working, and which give us false. And that is operator precedence and associativity rules. So usually, if you are not sure about the operator precedence and associativity rules, the most informed way is to using the parentheses to make the rules explicit. For example, here we write in this one. So if you don't know the operator precedence, but you know what you are going to calculate. So here you should write 3 plus, okay, we have to evaluate this thing first, right? And we're using a middle parenthesis to making the 5 multiplied by 7 to calculate. After that, since we are going to having the plus first here, one more parenthesis. Okay, after that, you will have a formula like 3 plus 4 multiplied by 4, right? And it bigger than 5 multiplied by 4 plus 3. Okay, I would admit that the parentheses are nested together, making you have to thinking more. However, it is really explicit, the operator precedence. In this case, you will know, okay, I should always calculate the inside parentheses first. Here is this one, and here is this one. And after that, I should break the outer parentheses. And here is this one, and there is this one. And after that, I still have parentheses, right? So I should break the most outer parentheses here. Once we break all the parentheses, and then we get the calculation. So those are things that is, I mean, easy, actually is easy to understand, but sometimes if you are not realizing such a thing, you may write a wrong code in your program. So debugging. And last lab, we have introduced using the IntelliJ idea to the debugger button to debugging our programs, right? So people skip this line, these slides. Okay. And all right, that is for today's course. We are going a little bit faster than expected. So let me see whether I should go through another slide. Okay, well, let's revisit some the logic operators and the loops. So sometimes you may feeling weird, like why we are going to using the logical operators, right? So When searching, you could say that looking for a result for Monet and his use of color, or looking for movies result for science, fi or crime, or looking for a van for SUV or not both. So in this case, we can using the logic operators to select everything that we want. Not everything, the specific thing. Like, for example, you want to select a rap music while it is singing using Spanish. So in this case, you should using the logic operator and to indicate, okay, you want to looking for a music that is belonging to the rap music and also belonging to the Spanish community. Okay, in between the green part is what you are looking for. And if you are using the OR operators, that means, for example, if you are looking for the merengue, and also it's supposed to be a salsa. If you are using the OR, that means as long as one of the criteria is met, it can be your result, right? So the whole thing, even though the two circles overlap together, the whole thing can be your answer. That is the logical operator OR. And for the exclusive OR, that means you have to select neither of the merengue or the salsa. That means no overlap between these two things, between these two communities. This is the exclusive one. So suppose here now you are going to print a string welcome to Java 100 of times. It would be tedious to have write the following statement of 100 times. So in this case, we can using a while loop, right? Or a if else statement something. I don't know. Since it's a loop, what we have learned is a while loop. So we can use a while loop to print such a thing. So we can, of course, the most naive way is to write 100 lines of salt, welcome to Java. However, we can also declare a count and using the while loop in this way. So here is the while loop flowchart, which we also have introduced something similar in our previous lecture. While the loop continuation conditions is true. So we will get into the statement which referring to the loop body. In the right-hand side, it is a concrete example. We first declare a count and we assign 0 to it. And after that, as long as the count is not over 100, and we will sort the welcome to Java. After each time we print out such a sentence, we increase the count by 1. As long as the count is smaller than 100, we continuing doing the same thing. Once the count becoming 100, that means the loop continuation condition is no longer satisfied. So we will jump out of this while loop. So we can trace for that. Here we initialize the count, and here the count smaller than 2 is true here. And then we output the welcome to Java. And count do the self-increment. Currently, it will increase to 1 here. And then the count, which is 1, is still smaller than 2. So we continuing the loop body, that is print the welcome to Java. And then count will increase by 1, and currently count is 2 now. And here the count is no longer smaller than 2, so we will break this while loop. And we execute the next statement of the while loop. And in last week, we also introduced something about the sentinel value, right? We usually we use a -1 to indicate sometimes the specific times that we should end of the while loop. So you may use such an input value to signify the end of the loop. No matter it is -1, or you can make it to be a specific value you feel comfortable. But in practice, -1 or the character Q is used pretty often. So such a value is known as a sentinel value. And here is a warning that do not use floating point values for equality checking in a loop control. Since the floating point values are approximations for some values, using them could result in imprecise counter values and inaccurate results. For example, considering 1 plus 0.9 plus 0.8 something until to 0.1. So while item is not 0, no guarantee items will be 0 here. And it will continuing sum the items and minus the items by 0.1. And after that, you will print some value. And here is the do while loop. Do while loop means that you firstly do something, and then you make the decision whether the loop continuing condition is satisfied or not. So that means at least there is one time you have to do the loop body. But in the while loop, while something is true and then do, maybe if in the beginning the loop continuing condition is not satisfied, the loop body may not even execute for one time. Maybe never execute. So that's the difference. Okay, and then that is for today's lectures, and for next week, we will formally begin to our for loops there. And after for loops, I think it will be a good time for you to do some LeetCode problems. It's better to start earlier because practicing the LeetCode problems takes time, and sometimes it's difficult to understand. All right. If you have some questions, you can stay and ask. Otherwise, you can leave now. So good night to everyone. Thank you.